Greetings, dear viewers of the Cross-Moda channel. In this episode, I want to step away from the main theme of the channel, which is motorcycles, and move into the world of off-road vehicles. Let's say a few words about screw-propelled vehicles. Let's talk about their history, concept, interesting models, and their applications, as well as the drawbacks and complexities of their design. Make yourself comfortable. We're getting started. There are many hard-to-reach places on planet Earth, and there are areas so impassable that even the most modern wheeled all-terrain vehicles or tracked machines can't make it through. However, there is a special vehicle in history that can handle almost any obstacle, except perhaps sheer cliffs. We're talking about screw-propelled vehicles. Let's define the term right away. A screw-propelled vehicle is one that moves by means of screw rotor propulsion. Structurally, this propulsion system mainly consists of a pair of Archimedes screws made from durable material and placed on the sides of the all-terrain vehicle's body. However, history knows of cases where Madden art was built with skis and a single screw. We'll talk about them further as the story progresses. The principle of movement for a screw-propelled all-terrain vehicle is simple. When they rotate, they push off from the mushy or liquid substance the all-terrain vehicle is moving on and propel it forward. Often, the screws are sealed and hollow inside, which allows the all-terrain vehicle to overcome water obstacles thanks to positive buoyancy. An all-terrain vehicle with this configuration has unique off-road capabilities in mud, snow, and ice conditions. It performs well as a water propulsion system on amphibious vehicles, but is usually not suitable for driving on hard surfaces, whether it's asphalt or concrete. On these surfaces, the screw-propelled vehicle will shake and experience much greater wear on its parts. It is worth noting that the screw rotor propulsion system causes damage to the environment. It easily cuts through the turf layer and plant roots. And this is what your garden might look like if you invite a screw-propelled vehicle over. Quickly move the environmentalists away from the screen. However, after examining the material thoroughly and in detail, we'll understand that screw-propelled vehicles are highly specialized machines that have never been mass-produced throughout their history. It's precisely that narrow niche that made such machines uneconomical to produce. So, when was this interesting concept invented? The screw, as a mechanism, has been known to humanity for quite a long time. As far back as the 3rd century BC, Archimedes invented a water lifting device in the form of a shaft with a continuous helical surface along its longitudinal axis, covered by a pipe. Later, this mechanism became known as the Archimedes screw. However, humanity came up with the idea of using a screw in a vehicle somewhat later, namely in the 19th century during the industrial era. Until that moment, it was enough for people to understand what a wheel was, how to put a cart on those wheels, and what or whom to harness to that cart to make it move. As far as we know, the first patent for a rotor screw propulsion system was authored by Thomas L. Jones under number US 2727 is dated July 16, 1842. Thomas L. Jones proposed this drive both for land vehicles and ships. Therefore, the next rotor screw propulsion system was designed and patented by the Swiss-American Jakob Morat. This event took place in 1868. Many sources give the credit to Morrow, but this is not correct. We need to search for information more carefully. 6 years later, in 1874, a certain Augustin Trudel also proposed equipping a vehicle with a screw propulsion system. In Tsarist Russia, an inventor named Durgin received a patent for screw-propelled sleds in 1900. For several years, screw-propelled vehicles were produced in very limited numbers, but the reliability of this claim is unknown. Other sources give credit to Aeropivy, an American inventor who patented a screw-propelled vehicle for the forestry industry in 1907. Soon, a prototype powered by an internal combustion engine was built. The all-terrain vehicle was tested in the state of Maine, and it worked well, but there were still problems with maneuverability on uneven forest roads. In fact, Peavy's invention turned out to be unable to compete with Alvin Lombard's locomobile. In 1914, the Englishman George Arthur Blockson also filed a patent for improving agricultural tractors using the above-mentioned design. In fact, there were more than 10 patents for screw rotor machines at the turn of the 19th and 20th centuries. There's no point in listing all of them. I've already mentioned enough for you to understand the context. During World War I, Canadian Cody, who worked at a Detroit munitions factory, built a small model of a screw-propelled vehicle with a fully enclosed cabin, designed as an amphibious landing craft. Cody tried to sell the idea to the American military, but they weren't interested. Also, during this period, screw drives adapted for cars to move on snow appeared in France and Sweden. The screw is located between the rear skis. The design had a number of drawbacks. Due to the small surface area of the skis, the cars would sink into loose snow, and the screw drive itself was far from perfect. That marked the beginning of screw-driven vehicles, and it was only a matter of time before new models appeared and production began in at least limited numbers. Now I suggest we take a look in chronological order at the most interesting, well-known, and unusual representatives of this family. In the 1920s, the first screw-driven vehicle went into serial production in the United States. The machine, nicknamed the Snow Devil, was a Fordson tractor that had its wheels replaced with an Amstead Snowmoto screw rotor module produced by the Snowmoto Company. The Snow Motors Company was founded in the 1920s by leading automobile manufacturers in Detroit. In fact, thanks should really go to Grandpa Henry Ford. It was claimed that such a tractor weighing 2 tons could pull up to 20 tons of cargo. This marvel of technology could reach a maximum speed of 15 km/h. Such converted tractors were used for their intended purpose in the northern regions of the United States. For example, they performed well in the mines of Alaska, as confirmed by newspaper publications. Snow tractors built at the Ford automobile plants were chosen by Captain George Hubert Wilkinson to transport gasoline for airplanes that were planned to be used in polar flights during his Detroit and Arctic expedition of 1926. It so happened that the time for delivering fuel to the ships was missed, and it was believed that snow tractors would be the solution to the problem. However, they failed, mainly due to the deep, loose snow typical of the interior regions of Alaska and the enormous fuel consumption. Sled dogs saved the expedition. After an incredibly difficult 63 days, they managed to haul enough fuel to Point Barrow to carry out some of the planned flights. But the expedition achieved very little. Richard Byrd also used the screw-propelled Fordson in his first Antarctic expedition in 1928-30, and here the equipment didn't perform very well either. In this chapter, I want to talk about Motor-Nart prototypes from the late 1930s with screw engines. There are many prototypes, but not much is known about them. We'll generalize. In 1922, George Tucker created the Motobob, a machine with a rotary screw engine. The rotor was powered by an air-cooled engine, with most of the weight resting on the skis. The Motobob snowmobile was designed only for traveling on snow, In 1926, the design was improved. Changes were made to the support and traction mechanism, resulting in only screw rotors remaining. In the state of Oregon, Emmett Tucker Sr. developed many prototypes of vehicles for snow, which led to the creation of his company in the late 1930s, later known worldwide as Tucker Snowcat Corporation. The first snowmobile with a screw engine, called the Tucker Spiral Drive Snow Sled, appeared in the early 1930s. As you can see, the skis on the sides were designed to compensate for the reactive torque of the single screw. Later prototypes by the same inventor featured two screw rotors in their design. In the end, Tucker, like his contemporary Joseph Armand Bombardier, arrived at the tracked drive. However, similar modern art projects existed in the Soviet Union in the 1960s, and we will look at them in a separate chapter. Screw-propelled vehicles, thanks to their off-road capability, inevitably attracted the attention of the military. After World War I, Army officials were looking for an alternative to the tracked propulsion. Yes, it may seem that a tank's track lasts forever. However, due to the huge number of moving parts, harsh operating conditions, and heavy loads, the service life of tracks is not that long. For example, modern rubber bush tracks on U.S. tanks last about 12,000 kilometers. That's less than the mileage you get from the tires on your car. But more than 100 years ago, on the most widely produced French tank of World War I, the Renault FT-17, the service life of the running gear, particularly the tracks, was only about 120 to 150 kilometers. That's why, a century ago, the screw propulsion system was seen as an alternative that could solve the problems of the tracked vehicles of that time. For military purposes, work was being done on various types of screw-propelled vehicles, ranging from light reconnaissance vehicles to tanks, all using screw propulsion. Most of these projects never went beyond drawings on paper, but a few of them were actually built in metal. The first was called Weasel. At the start of World War II, Jeffrey Pike, a participant in the Wilkes expedition, yes, the same one where they tried to use the Fordson, Snow Devil thought he could build a vehicle with a screw drive, similar to a snow tractor, to move the Army across snowy terrain. Since 1941, Lord Mountbatten, the head of the Combined Operations Department, had been planning to build this machine, and Pike moved to Canada to oversee the project, which failed. However, this soon led to the creation of the more versatile M29, Weasel-tracked all-terrain vehicle, which was built in a total of 16,000 units at the Studebaker plant in the United States during the World War II. The Germans also experimented with screw-propelled vehicles during World War II. German officer Johannes Rettel. He gained fame and was featured in newspapers for transforming an ordinary tractor into a uniquely designed all-terrain vehicle. A veteran of battles on the Eastern Front, Rettel decided to create a machine that would help the Germans cope with the harsh conditions of the Russian winter. At the beginning of 1944, he successfully tested the Schraubenantrieb Schneemachine in the mountains of Tyrol. But by that time, Germany was already in no position to pursue projects like that. Then, in 1944, there was a proposal from a technician, Lieutenant Grigorenko, to equip some existing vehicles with a screw propulsion system. A much more radical prototype was proposed back in 1942 by engineer Beketov. The designer proposed creating a snow tank about 7 meters long and weighing around 28 tons with 4 turrets from the T-26. All the ideas remained on paper. After World War II, the military's interest in the screw-propelled drive gradually faded away. The requirements for military equipment were clearly defined, and most importantly, by the late 1940s and early 1950s, the lifespan of military vehicle tracks had increased several times and already reached 36,000 kilometers. This became the fundamental factor. In this chapter, I'll discuss foreign screw-propelled vehicles from the second half of the 20th century. The vast majority of this equipment was designed to tackle difficult terrain in civilian sectors, whether it was geological exploration or rescue operations. But there were also a few cases of attempts at combat use. An interesting vehicle was invented, patented, and built as a single prototype by a Californian named Elvin Becker. In fact, it was a kind of motorized tow sled with screw propulsion, which could pull loads behind it, or, for example, help a pair of skiers get up a snowy hill. The project wasn't developed further. A very interesting concept was patented in 1966 by an engineer named Casimir. This is a screw-driven vehicle with 4 independent screws positioned at 90-degree angles. In theory, the vehicle was supposed to perform more confidently on solid surfaces, but its speed was even lower in theory than the already low speed of classic screw-driven vehicles. I'm scared. The next machine was a production screw-propelled vehicle from Chrysler Corporation. In the early 1960s, Chrysler Defense Engineering was working on amphibious vehicles using a screw-rotor propulsion system. And in 1963-64, the Chrysler Mesh Screw Amphibian appeared, which was equipped with a Chrysler Slant 6 225 engine producing 116 horsepower. The all-terrain vehicle weighed 1.5 tons. The vehicle was capable of reaching a speed of 22 km/h on mud, 13 km/h on water, and 32 km/h on snow. A total of 10 units were built, and at least one of them still exists, apparently preserved in storage by the U.S. Army. As of 1964, the military had abandoned the use of the amphibious vehicle from Chrysler. Against this backdrop, the auto giant used the attention-grabbing vehicle as a public relations tool to draw attention to its products. For traveling on public roads, Chrysler introduced a screw-propelled vehicle in 1965, equipped with additional retractable wheels. Despite the disappointing results, Chrysler still built a much larger all-terrain vehicle in 1969, the Riverine Utility Craft, or RAC, which moved on 2 aluminum screws with a diameter of 11 mm, and was powered by 2 Chrysler engines with a displacement of 6.7 liters. The U.S. Navy conducted tests of the RAC screw vehicle in southern Louisiana and Southeast Asia. The speed on water was 25 km/h on swampy terrain, 46 km/h, but on solid ground the speed dropped to 7 km/h. Tests in rice fields showed a tendency for the RAC to get caught on earthen dikes. Chrysler built 10 units for the Marine Corps in Vietnam in 1969, one of which was armored. That was the end of the screw-propelled all-terrain vehicle story from Chrysler. Another interesting machine is the DAF Ampferol, and yes, this machine is connected to the DAF truck brand. Joseph D. Backer built the screw-propelled vehicle, Ampferol. Joseph was an avid fisherman, and he was terribly annoyed by the fact that he had to adjust to the schedule of tides just to enjoy his hobby. Backer thought that the Amphibia all-terrain vehicle would be a good solution to this problem. The inventor was also driven by commercial interest. Such all-terrain vehicles could be in high demand in his home country. The first all-terrain vehicle was built in 1966 and was equipped with 2 750cc engines, each fitted with a DAF variomatic transmission, one set for each auger. The vehicle could reach speeds of up to 35 km/h on silt. Later, the vehicle was powered by a marine rotary engine, the NSU RO 135. Then, a Ford engine with a Sandstrand hydraulic transmission was installed in the all-terrain vehicle. The auger control system was interesting. Usually, parallel augers, as in the case of Ampferol, could change their angle relative to the longitudinal axis of the vehicle, which improved handling. Here in the illustration, this mechanism is clearly shown. Unfortunately, Joseph D. Backer's creation did not gain much popularity. However, these photographs confirm that a certain number of Ampferols were built. This one, for example, was used in the rescue service. Japan, to my surprise, also tried not to fall behind in creating screw-propelled vehicles. In 1966, a machine called Dorosi was created with 4 screws and a drive mechanism in the middle. The maximum speed of this machine was 20 km/h. However, among Japanese manufacturers, The Mitsui Corporation was the most successful in this field. In the second half of the 60s, a prototype of the screw-propelled vehicle AST-001 was built, which could move across the sea and break through not too thick layers of ice. The vehicle has a carrying capacity of 1.6 tons, a speed of 9 km/h on land, and almost 6 km/h in water. The next model, Mitsui AST, was built in 1985 with only 2 built, of which only 1 has survived. With a weight of 11 tons and a V12 diesel engine producing 300 horsepower, the all-terrain vehicle was capable of carrying 5 people at a speed of 11 km/h on ice and 8 km/h on water. The payload while afloat was 1 ton. The real heyday of screw-propelled vehicles was from the 1960s to the 1980s in the Soviet Union. During this period, Soviet engineers developed more than 20 different designs ranging from lightweight motor sleds, weighing 230 kg, to 13-ton giants. As in the rest of the world, most screw-propelled vehicles in the USSR were produced as single prototypes, and only a few were made in small numbers. However, no matter how you look at it, more screw-propelled vehicles were created in the Soviet Union than in any other country. And I want to start this chapter with the creations of the Gorky Polytechnic Institute. The All-Terrain Vehicle Research Laboratory of the Gorky Polytechnic Institute built an impressive number of machines with a rotary screw propulsion system, hereafter referred to as RVD. Among the GPI's machines, there were both unique prototypes and quite utilitarian vehicles, some of which even worked quite well in very specific environments. The initiator of this work was Vologdin, a participant in the Great Patriotic War, a 1951 graduate of GPI, and a senior lecturer at the Department of Machine Parts at the Institute. His first work in this field in 1963 were the GPI 16 motor sleds. Basically, these were GPI 15 motor sleds on which a rotor screw module was installed instead of a tracked one. The 500-kilogram snowmobile was powered by an IJ Planeta engine with 12 horsepower located in the front part of the vehicle. The machine demonstrated good driving performance and inspired Vologdin to create even lighter vehicles. In 1964-65 he designed, and with his direct involvement in 1967, a lightweight, floating, single-seat screw-propelled vehicle called GPI 16 VA was built. The vehicle had a fiberglass body with a ski-shaped bottom and a motorcycle engine located in the rear section. Tests showed that the rotor screw drive could provide movement of the vehicle over snow of varying depth and density, but due to constant drifting and involuntary swaying from side to side, the controllability was clearly insufficient. In 1967, engineer GPI Zakharenkov designed the ski screw motor sleds, GPI 16 VS, and in 1971, the GPI 05 motor sleds. These were more advanced versions of the GPI 16 machine, and they also turned out to be almost twice as light as their predecessor. Both snowmobiles were built, sent to the customer, and were used for a long time in Kamchatka. Another area that the Gorky plant worked on besides motor sleds was the design of rotor screw swamp vehicles. The first in this series was the RVB GPI 02. The vehicle was manufactured and used by the Kuryanovsk Aeration Station Association for treating sludge beds at wastewater treatment facilities. Its testing and operational experience made it possible to create the RVB GPI 06 machines and the GPI 3906 modification with a diesel engine. During the same period, under the guidance of Doctor of Technical Sciences Nikolaev, a number of screw-propelled vehicles were created at the Department of Construction and Road Machines of GPI for use in the Arctic and Antarctic. I would like to note that in many sources, the abbreviation GPI is used for this equipment. However, I will use the abbreviations that appear in the works and articles of the Gorky Institute itself. The first among them was LFM 66, created in 1966. The screw-propelled vehicle was based on the GAZ-47 tracked all-terrain vehicle. Work in this direction developed successfully. Following the LFM-66 in 1971, the LFM-72 all-terrain vehicle appeared, built on the basis of the GAZ-66 truck. The speed of the LFM-72 screw-propelled vehicle on a swamp reached 25 km/h and up to 10 km/h on water. A year later, two models appeared, PTV-84 and RVVP-68. The PTV-84 weighed 2 tons and was equipped with a 115 horsepower engine. The RVVP-68 was a bit lighter and less powerful, but in addition, it also used an air cushion to offload the screw rotor propulsion system. In 1973, the 6-ton 115 horsepower screw vehicle LFM-75 appeared. In 1976, the VM-99 saw the light of day. A year later, the RVT-85 appeared, weighing 13 tons and equipped with a 240 horsepower engine. In 1981, the SLU-119 model appeared, which can be classified as a light screw-propelled vehicle. It weighs only 1.2 tons. Another enterprise in the Soviet Union that was actively involved in the field of screw-propelled all-terrain vehicles was the Likhatchev plant. Work on creating vehicles equipped with rotor screw drives at ZIL began in 1966, when the chief designer of the ZIL Special Design Bureau, Grachev, suggested that the leading specialists of the Bureau watch a film that had somehow been obtained. The 12-minute film demonstrated the capabilities of the American Swamp all-terrain vehicle MSA developed by Chrysler. Yes, we've already talked about it. The vehicle being developed by ZIL engineers received the official designation SHN-67 and the unofficial name Schneck. The SHN-67 snow and swamp vehicle was equipped with a ZIL 375YA engine and a ZIL 135L hydromechanical transmission. 2 Schnecks served as propulsors placed on each side. They were hollow cylinders with cones at both ends, made of 2 mm thick steel sheet. The vehicle weighed 4.6 tons and was equipped with a 180 horsepower engine. Test results led to a decision to upgrade the screw-propelled vehicle. Instead of the heavily worn steel screws, the new model designated SHN-68 was equipped with screws made of aluminum alloy and a different screw profile. The SHN-68 was assembled in March-April 1968. On May 6, it was tested on a body of water. A speed of 12 km/h was achieved while afloat. However, during the tests, a characteristic drawback of the machine was noted when the screw vehicle was coming ashore. The winter tests of the SHN-68 were conducted in the northern part of the Perm region, on loose snow, with an average air temperature of -8 degrees Celsius and a snow depth of about 1 meter. Scientists at the Kiev Automobile and Road Institute were interested in tests of the screw-propelled all-terrain vehicle. For them, a special test stand for studying the rotary screw propulsion unit was designed and built at the ZIL Special Design Bureau, where scientists from the Kiev Automobile and Road Institute conducted research on models of rotary screw propulsion units with various rotor diameters and screw blade pitch angles. The successful tests of the prototype of the SHN-68 snow and swamp vehicle sparked interest in this type of machine from the Air Force Search and Rescue Service, and such an all-terrain vehicle was needed for the evacuation of landed cosmonauts. Yes, you heard right. It so happened that in the USSR, the descent modules of spacecraft with cosmonauts landed on land. But the land can be different. It could be the steppes of Kazakhstan, or it could be an impassable swamp in the tundra, or the remote taiga wilderness. And there may be a situation where only an all-terrain vehicle can handle the task. You might wonder why the US didn't build screw-propelled vehicles for astronaut evacuation. After all, the US, like the Soviet Union, was at the forefront of space exploration. Ultimately, it all depends on the landing procedure. In the US, the modules mostly landed in the water, and for evacuation, naval and aviation forces were enough. According to the Air Force's technical specification, the ZIL Special Design Bureau began work on creating a prototype snow and swamp vehicle with a screw rotor drive, designated PU3 or 4904, capable of carrying out rescue operations in swamps, frozen bodies of water, and deep snow without any limitation on snow depth, to evacuate both cosmonauts and descent modules. The vehicle was built in 1972. During field tests, the PU-3A was found to have insufficient maneuverability when moving over floating vegetation compared to the SHN-68. When turning, the vehicle tended to veer toward the direction of least resistance. Movement on water along a set course with a crosswind speed of more than 5 ms required frequent steering corrections. Due to the high windage of the snow and swamp vehicle, the Giant was an interesting machine, but it did not meet the requirements. Therefore, as early as 1972, work began on the screw-propelled vehicle ZIL-2 906. The small size of the vehicle,
Длина 3,8 метра, ширина 2,3 были обусловлены.
Matched the dimensions of the cargo compartment of the wheeled all-terrain vehicle ZIL-4 906, which was intended to transport it to the work site. The concept of the search complex was revised, and it was named ZIL-4 9061 Bluebird. According to the design, the ZIL-4 906 would carry the snow and swamp vehicle in its cargo compartment for as long as it could keep moving. When the terrain became impassable, the screw-propelled vehicle was unloaded onto the ground using the standard crane system, and then it would continue the search for the descent module on its own, evacuate the cosmonauts, and tow the module on a flexible tow line to the wheeled vehicles of Complex 490. The preliminary layout of the screw-propelled vehicle, which received the factory designation ZIL 2906, was completed on August 20, 1973. In order to minimize the weight and simplify the design of the new all-terrain vehicle as much as possible, it was decided to use two MMZ 967A air-cooled engines each, with a power of 37 horsepower. The open passenger cabin was designed to have seating for 2 crew members and 2 recumbent positions for cosmonauts. On August 21, 1975, the ZIL 2906 began water testing. Almost immediately, numerous defects were discovered in the operation of the Melitopol engines. When moving on water, they operated at full power, but the vehicle's maximum speed of 1012 km/h was not high enough for the incoming airflow to cool them sufficiently. In October, the snow and swamp vehicle was tested on swamps and drained ponds, and here the engines also did not perform well. The available power was not enough due to increased resistance, and the engines often broke down. To increase the specific power and improve the reliability of the vehicle, it was decided to use 2 liquid-cooled engines from a Zhiguli car. However, they could not be installed in the engine compartment of the ZIL 2906 without a major redesign. In fact, it was necessary to design a new vehicle. As a result, ZIL specialists concluded that it was necessary to develop an improved model of the rotary screw snow and swamp vehicle. According to the designer's plan, the new screw vehicle, which received the factory designation ZIL 2 9061, was supposed to be somewhat larger than its predecessor. On the one hand, this increased its stability on water and when moving through steep snow-covered ravines, and on the other hand, it made it possible to install 2 more powerful liquid-cooled engines from the VAZ-2-103 passenger car on the vehicle.
ЗИЛ-29.
The ZIL 29061 was produced in small batches from 1979 to 1983. In the early 1990s at the ZIL Special Design Bureau, a modernized version of the screw-propelled vehicle, the ZIL 29062, was developed at the request of the state corporation Transneft. The project was successfully approved, but when it came to organizing mass production of the new screw-propelled vehicle, both the plant management and the customer lost interest in it. As a result, the Transneft Corporation purchased a single production ZIL 29061 as part of the 490 complex for delivering repair crews and servicing pipelines. In addition to GPI and ZIL, there were plenty of enthusiasts in the USSR who built their own screw-propelled vehicles. In that year, engineer Gavrilov from Temirtau proposed converting a standard Pobeda car by installing 2 screws and front steering skis on it. The screws were mounted on special brackets without any suspension elements and were driven by drive shafts. In 1973, engineer Olinikov from the village of Zarachensky in the Murmansk region built the screw-driven sled Crab 1. Credit must be given to the persistence of this technical enthusiast. It took 3 years to make the machine not only operational, but also reliable. Additionally, it can be noted that various models of special transport and technological machines equipped with rotary screw propulsion units were created privately at mining enterprises, land reclamation bases, and aeration stations. And now, my friends, we have reached the 21st century. In the new millennium, some companies and design bureaus have been and continue to be engaged in the design and construction of screw-driven vehicles. However, in terms of application, almost nothing has changed in nearly a century and a half. Even today, the screw-driven vehicle remains a very rare and specialized product. I'll say a few words about modern models. One of the most interesting and once widely discussed vehicles is the Snowbird 6. A bold combination of a tracked truck and a screw-driven vehicle built as a one-off with a single purpose. British men Steve Brooks and Graham Stadford conceived the idea to cross the Bering Strait under their own power using this extravagant design. To build this machine, the company Ice Challenger took a tracked truck and attached 2 powerful augers to it. When it was necessary to switch from tracked movement to auger movement, the rotors were lowered below the tracks using hydraulics, and the machine turned into an auger-driven amphibious vehicle. The machine was required to move. In 2002, an expedition on the Snowbird 6 successfully traveled across the ice of the Bering Strait from the village of Providenia in Chukotka all the way to the city of Nome in Alaska. The machine fulfilled its purpose, but there were a lot of nuances and not so much technical as bureaucratic. During the British team's first attempt to cross the ice, they were simply turned back by the border service due to the lack of some paperwork. Let's go. Do you remember the GPI vehicle? So the city is now called Nizhny Novgorod instead of Gorky, and accordingly, the name of the higher educational institution has changed a bit. Now it's called Nizhny Novgorod State Technical University. However, the Soviet-era developments are still there. The institute, with the support of the All-Terrain Vehicle Plant LLC, continues to develop transport and technological platforms with rotary screw propulsion. The ZVM Enterprise was founded in 2004, and a few years ago, in addition to tracked vehicles and equipment with ultra-low pressure tires, the ZVM 2901 screw-driven vehicle appeared in the product lineup. The screw van comes equipped with a choice of 2 engines, the YAMZ 5344 or the MMZD 245.7 with 135 and 119 horsepower, respectively. The vehicle has a payload capacity of 1.5 tons. Its maximum speed is 25 km/h on ice and 10 km/h on water. In the standard configuration, the vehicle is equipped with a 2-seat cabin, an engine heater, and a power takeoff shaft for operating technological equipment. However, at the customer's request, and of course for an extra fee, the all-terrain vehicle can be additionally equipped with extra seats or equipment. The price on the official website is about 6 million Russian rubles. The second all-terrain vehicle with a rotary screw propulsion system is the ZVM 2902. This vehicle is equipped with the same engines as the ZVM 2901 and has a slightly higher payload capacity of 2 tons. The Sinyaya Petitsa complex also remains in service, with about 20 units having been built. This complex is still in demand today during search operations for the evacuation of landed cosmonauts, as well as in the oil and gas industry. And here before you is the Shnykokhod system patented by Alexei Burdin from Russia. The idea is that the first screw-driven vehicle located between the spiral blades of the screw acts as a tire to absorb shocks and increase speed on hard surfaces. And here are sketches of prototype vehicles that use this idea. Right now on the monitor, you are seeing a modern platform using the Schneico system from Australia. This is the Mudmaster from Residue Solutions. The Mudmaster is a fairly simple machine in terms of design, consisting mainly of a frame made of steel beams, with auger suspension units attached at the corners. A platform is mounted on the frame, where the diesel engine and the driver's cab are installed. The 8-meter Mudmaster weighs 18.5 tons and is powered by a 6-cylinder Cummins diesel engine. Each unit of the screw-propelled vehicle is assembled to order. The assembly process takes 18 weeks. Articles have widely circulated on the Russian-speaking internet portraying this screw-propelled vehicle as a kind of universal machine, a platform on which supposedly any equipment can be installed. It's possible that for an additional fee, the manufacturer will install extra equipment for you. However, the Residue Solutions website doesn't mention anything at all about installing any equipment on the screw-propelled vehicle. The main task of Mudmaster is quite simple: compacting and dewatering ore residues, the so-called tailings. Mudmaster slowly drives back and forth across the sludge storage, mixing the sludge and squeezing water out of it with its weight. The water then evaporates. In 40 days of such work, the screw-propelled vehicle turns liquid mud into dense and solid ground. It is known that such a screw-propelled vehicle is used at the Nikolaev alumina plant. That's in Ukraine. Amphicat is another modern, mass-produced, screw-propelled vehicle originating from the commune of Pira in Austria. This is a real giant in its family, with a length of 12 meters 30 centimeters and a weight of 19 tons without the excavator module. The machine is equipped with a 326 horsepower engine. According to information from the official website, the screw-propelled vehicle is intended for various uses in hard-to-reach areas. In particular, it is used for servicing reclamation canals. A couple of weeks ago, I sent an email to the official Amphicat address to find out more details, but unfortunately, I never got a response. Well, never mind. We also can't ignore unmanned screw-propelled vehicles. The remote-controlled autonomous robot STAR, which stands for Spiral Track Autonomous Robot, was developed in 1996 at the Livermore National Laboratory in California. It was positioned as a spy robot, a radiation detector, or a mine detector. Another one, the Helix AR2, is an amphibious robot weighing 600 kilograms with a central turret designed for deploying tools. The Helix is used for sampling in sludge storage facilities, eliminating the need for humans to be present in these hazardous areas. The robot is controlled by a remote with a range of up to 2 kilometers at a frequency of 2.4 GHz, like a quadcopter. The device is manufactured in Canada. In addition to factory-made screw-propelled vehicles, both now and in the past, there have always been enthusiasts who build all-terrain vehicles with screw drives on their own. Often the decision to build such a device is driven by simple necessity, the need to make travel and work easier, and so on. The same call-in FARs or garage-built screw-propelled vehicles. But that was already done more for hype and just to show like, look, we can do it. Finally, I want to say a few words about boats and motorboats with screw modules. Such vessels were and are being built for specific tasks as well. The screw rotor propulsion system is useful for traveling through bodies of water full of aquatic plants, where regular propellers instantly get tangled with algae. This kind of screw module can also break ice up to a certain thickness. Here, for example, is the experimental icebreaker Gorinko, 25 meters long, built in 1987 for use in Alaska's oil fields and later converted into a cruise ship. The main feature is the 4 propellers installed under the front part of the boat, which are used to break up ice that isn't too thick. Over 10 seasons up to 1996, it carried 80,000 tourists. Currently, the vessel is on display at the Monbetsu Marine Park Depot on Hokkaido Island, Japan. The new Gorinko, 235 meters long and with a capacity of 195 passengers, was built in 1997 and is still in operation today. Friends, as you can see, screw-propelled vehicles are a very rare class of all-terrain machinery. And this is not due to a conspiracy by a secret government, but simply because vehicles with rotary screw propulsion are extremely specialized. For example, the Bluebird Cosmonaut Rescue Complex. You can clearly see that the screw-propelled vehicle is only used in absolutely impassable terrain, while in all other cases, it rides in the bed of a wheeled all-terrain vehicle, which is more economical and versatile in choosing routes. And here's proof of that fact. Here is a graph showing the relationship. The speed of the screw-propelled vehicle compared to boats, whose speed increases once they reach sufficient water depth, and compared to wheeled and tracked all-terrain vehicles, where the speed is higher, the firmer the surface. According to the graph, the screw-propelled vehicle is actually good in boggy swamps, thick mud, and snow. It's interesting that serious studies on the efficiency of the screw as a propulsion system were only conducted in the early 1960s. The pioneer in this research was the scientist Cole from the United Kingdom, and around the same time, scientists from GPI also conducted serious studies on the physics of the screw. During this work, the most optimal ratios of diameter, length, height, and crest angle were determined. Based on these scientific studies, it turns out that the best ratio of screw diameter to length is 1:6. The optimal crest height is 1/8 of the crest. The optimal angle of the crest to the screw axis is between 30 and 40 degrees. If you plan to build a screw-propelled vehicle, remember that. This is a very interesting point. In fact, screw-propelled vehicles were built purely empirically for the first 40 to 50 years. That is, you build it, but you won't know how this vehicle will run until you try it. The future of screw-propelled vehicles is quite clear. They will remain a niche type of all-terrain vehicle for specific conditions. However, due to the emergence of new structural materials and composites, as well as modern concepts of rotary screw propulsion, it is possible that the range of applications for this technology will expand. With that, dear viewers, my brief overview of screw-propelled vehicles comes to an end. In the 3 weeks I spent working on this material, I had to sift through up to 100 articles and web pages, ranging from tabloid pieces full of not entirely accurate information to term papers from the Gorky Polytechnic. I hope I managed to tell you about vehicles with rotary screw propulsion in an interesting, clear, and humorous way. These 45 minutes, or however long it turned out to be, flew by before you knew it and were worth your while. The future of this material is in your hands, so don't be lazy. Give it a like, write a comment, and share the link with your good friends. Let them watch it too. Besides that, you can support the channel with a donation using the details provided in the pinned comment. Thank you very much for your attention. See you next time.